Hello all. Let's solve this problem say in today's contest. So by seeing this problem, like we will overthink lot many things because we can see there are colors and there are different queries. We will think whether it can be implemented using tree, graphs, or many other things. But it's like a very simple problem and it's pretty straightforward as well. If you understand the question carefully, then you can solve it very easily. So let's understand the question. So there is a zero indexed array nums of length n. Initially all elements are uncolored, so the all values would be zeros. 0 0 0 0 0 0. So from 0 1 2 3 4 5 all colors are 0, and he has given a 2D integer array queries. Like for index he's given some color. He's starting from the index 0 because he has mentioned over here, like from here 0 it is starting, and for each query you have to color the index with the color I in the array. For each index, suppose here the index is 0 and the color is 2, we have to color it with 2. So we need to return array answer of the same length as queries, where answer of I is the number of adjacent elements with the same color after the ith query. Like example, like if the color is 1 1 2 0 2 3, and here we can say that the adjacent color is 1 1. So how many are there? Only one. And here there is no adjacent there, so we will declare as one color which is adjacent to each other. Suppose there is 3 over here, then we will tell 3, and 0 comma 0 is not valid because it's not colored yet. uh, and for more formally, we have to store that in the answer, and it's shown that if the nums of j is not equal to 0, we should not calculate. So I think you got the question, so let's understand this example. So is colored at index 0 with 2, index 0 with 2. So the answer, what the answer would be? No, it's index 0. Yes, let's copy this and let's paste it, and because we can forget. Okay, yeah, we got this. At index 0 you have painted with 2. Now the what? 2 0 0 0. How many adjacents are there? Only one. Oh no, only 0, because 2 adjacent to 2 is 0 and it is not colored, so it is 0. So index 1 is colored with 2. 2 2 0 0. At index 1, so how many adjacents are there? 1. For this it is adjacent to this. It's we need to go in a forward direction because he mentioned over here nums of j is equal to nums of j plus 1, and only unique things are included. And at index 3 he had colored with 1, and we can say there is no color, only 1 is there because 2 2. And now at index 2 is colored with 1 2 2 1. How many colors are adjacent and which are same color? 2, because this 2 and this 2. And there will be few cases where the numbers will get override. So let's see. Suppose we are over here and there is a new test case called uh, at index 1 you have colored with 3. Like continuation to this, at index 1 is colored with 3. Now how many colors are there? Only 2, because it's get override and there are no colors at this point. So I think you got the understanding. Let's easily implement this. Don't overthink about that, what he had informed in the problem. Let's implement and let's see. Like I solve this problem in the contest, I will explain you very easily. So let's copy this and let's paste over here. See, and here we are v is like an answer. We are storing all the answers over here in v, and here we are taking the count, global count, because at each and every point we need to check. And a is an index and b is an color. A is an index, b is a color. Yeah, from the next videos I will try to use good variables so that you can understand it very clearly. and we will check like if v of a is not equals to 0, because v of a is not equals to 0, then it may override. So what we will do, we will check a minus 1 greater than 0, and if there is an adjacent element which is equals to v of a, then we will decrement, because you can see like here it's getting override, this step here it's getting override, and we need to check for 2 there is adjacence, there is 2, so we need to decrease it, because now it is overriding and the adjacency is invalidating. So in that way we need to override, we need to minus, and in the same case if there is an element which is next to it, and we need to subtract, and then we need to override it, v of a equals to b, and we need to check like if we a minus 1 greater than 0, and now we are updating. Suppose now suppose let's take like this 3 2 2 1 1. Now 2 is getting updated to 1. huh? Now for 2 we are decremented, until here we until this step we have decremented, and now we are overriding it with 1 1 1. Now for this one we have adjacent to 1 which is the same color, so we will increment the count, and we will check with this as well, and if it is not equal we will not perform any actions. As simple as that. Here we are checking, here in that case we are not incrementing, and if it is equal we are incrementing, and we are pushing the answer into this, and we are returning it. So I think most of the people have done mistakes, and there are a lot of people who are disliking this because they did I think they did not read the question properly, and they are overcomplicated, because colors, adjacency elements, we see this all things, we'll think about trees, graphs and anything. Let's read the question and let's understand how it can be solved, and then you can think. Don't make assumptions like if this is a color adjacency elements, it should be something which is very complicated data structure. You can see like this is a very simple and greedy solution. I think most of the people can solve, like even the beginners can solve this problem very easily. And let's see what will be the time complexity for this solution. It's like order of n, because we are iterating order of q. So how many elements are present in q, sorry, in this, and the space complexity would be order of n, because we are using a new vector. And thank you guys, thank you for watching videos. Thank you.